Hello, Dr. Rafiq.
Hey,
Thanks for
cool.
meeting me today
Nice to meet you.
and for talking to us about our research project together
No
with
problem.
REAC. So, as you know, we're very interested in dioxins because of that research we did when we filmed My Life as a Plastic Bottle. And I wanted to know if you can talk about the different types of plastics. We know that there's dioxins are created when plastic is burned, but not necessarily when it's melted. Can you tell us more about that?
Yeah, so we have recently done some research in looking into dioxin to see like how we can actually measure them and how they are actually created. And we have seen that there is a big correlation with plastics, especially when the plastic is burned in incineration in other processes. So one of the things which we are interested in looking into when we are melting plastics, especially with 3D printing technology, to see if we are actually measuring or if we're creating any of these dioxins, because these are very difficult to detect particles, and we need to know what's happening with that.
Yes, we want to know about that too. So one of the research partners pointed to volatile organic compounds as something that's usually created when melting plastics, but those are, some scientists link dioxins or lump dioxins in with volatile organic compounds, but we want to make sure we treat them separately. Can you tell us more about the total volatile organic compounds that are possibly created?
So there are many types, right? I would be able to kind of talk about the different types of TVOCs created, because there are so many of them, and it depends on what process, which material do you use. There are certain TVOCs which are associated with plastics, especially if you're burning them. So those are the things which are important and we need to detect them. But then there's also a threshold value of 0.6 ppm, which usually is kind of considered as a safe level. So if there are more TVOCs above that level, then that is considered dangerous or hazardous for humans. So that's why we need to kind of continuously monitor and kind of identify those. So we kind of, in general, in the space area, especially if there are companies around us, we can see that in the environment there's find some TVOCs, but not a lot above the threshold, right? So we need to be, as human, monitoring these kind of TVOCs and seeing if they are not above that limit, and wherever there's above limit, then we need to take proper precautions. So we have done some testing in our lab as well, looking into some of these TVOCs generated from our 3D printing process, and we did some thorough testing on that, and we realized that we are not generating anything above the limit. So we are always at 0.4 or something. So it's a very safe limit for humans.
Excellent. Yeah, we did, and thanks for the loaner of the total volatile organic compound sensor, because we did a bunch of background, looking at the background levels of TVOCs, and even in the river valley we found them to be 0.4 during a very cold winter day when there was a winter inversion pushing all the pollution down. So yeah, they're out there from traffic, from other things too, but we want to make sure we're wearing PPE if it gets above the threshold for humans. So thanks for doing all of that. So we're looking at dioxins separately. We've separated it out from the other volatile organic compounds because it's special. There's no threshold for dioxins. It's more hazardous for human and environmental health. Can you expound on that, or do you have any more to say about the difference?
So the reason we have been looking into it separately is because it's super hard to detect dioxins, right? So it's not that easy to kind of measure them with any of the existing technologies or sensors. So that's why you have to measure TVOCs, but you also need to look into dioxins. And dioxins are not there everywhere. It has to be specific circumstances for plastic to be burned or things like that. So that's why dioxins are not everywhere. So that's why a lot of these facilities or places where they monitor some of these particles, they don't look for dioxins because technically from the literature they can feel or they can sense or they can realize based on the research that those doesn't exist. In our case, we still want to make sure, so we are still looking into dioxins from our research perspective. perspective to see if we are even detecting any of these dioxins. And one of the interesting part which we are interested in is kind of measuring dioxin while we are actually 3D printing with the virgin plastic, and then also maybe testing it with recycled plastic to see if there is any difference between these two. So that's why like we need to, dioxins are special and we need to treat them special. And that's why we will need to kind of come up with a new way of how to monitor that. There are some technologies and equipments available, and people have been looking into the research part on how to measure dioxin, but those equipments are very expensive, very complicated technologies, so which you cannot just use anywhere outside, so it's not that easy. So what we are interested in doing with the dioxin is to kind of capture the air around the 3D printing technology, and we use that air to kind of pass it through a filter, and then we use that filter to send it to a certain lab, specialized lab, who are specialized to test dioxins. So we are working with them to kind of see how we can actually send it to them, and then they will measure if there is any dioxin we are generating or not.
Yeah, thanks a lot for working with that specialized lab to develop the protocols around measuring dioxins. We don't expect to be placing dioxin measurements in the different plastic remanufacture facilities because we need to have the information first.
Yeah.
So that thanks for doing all of that and that research into making sure that the protocols are strong and that the monitoring for dioxin is appropriate to recycled material specifically as well as the virgin plastic.
So one of the things I just want to add there as well is that with the traditional or existing 3D printing technology, we are not melting any of the plastics. So we are pretty safe environment, and it's being tested by many people. So a lot of research has been done to see that there is no dioxin generated, right? So with the existing technology, we don't have any issue. But if you're recycling plastic, that's where we don't have research available currently. That's why we want to do this specialized testing on dioxin to kind of make sure that there is nothing we are generating with our new technology which we're creating.
And we want that too, because we want to make sure that recycling facilities are available for rural, remote, and indigenous communities who want to take ownership of their own plastic waste.
That's right.
Because it can be remanufactured into other things up to 5 or 7 times, you were saying?
Yeah, it depends on the plastic. That's another thing which we are kind of exploring to see how many times a particular plastic can be recycled. So we still don't know. That's an unknown mystery, depending on whatever the product is, whatever the plastic is, and whatever the previous circumstances of that plastic is. But we want to kind of test that, and we are working on kind of creating a library for people to use, protocols to use, especially in the safety side.
Excellent, thanks so much. I see what you mean about the different circumstances around the plastic. For example, if a plastic pail has been left outside for a while and been exposed to the sun, it's going to be very brittle. It will have lost some of its benzene, some of its greenhouse gases because of the sunlight exposure. So that's going to be a different, more challenging plastic to recycle then.
Yeah, and the functionality of every product is different. How, like the same product, same plastic can be used in different circumstances, but at the same time, if we're talking about mixed material, all those things makes it more complicated. So there's a lot to do. Still, we need to investigate some of these areas, but especially the special parts of the TVOC, dioxin, all these things are very important, and we need to make sure that if technology like what we are developing, it goes out to the field or to the people's houses, it should be safe.
Awesome. Thank you so much, Dr. Rafiq.
Thanks, Jill, for coming.